Alright, today what we're going to be talking about are trapezoids and kites. Up to this point, we've been working primarily with this part of our quadrilateral family tree. Alright, so we've been working with parallelograms, rhombuses, squares, rectangles. But we've been neglecting our other side, our kites and our trapezoids. So this is what we're going to be talking about today. Alright? So, first of all, just as a reminder, what on earth is a trapezoid? Well, a trapezoid has a few different characteristics. All right, it's a quadrilateral with exactly one pair of parallel sides. All right, so for example, we have side AB is parallel to side BC. All right, then we also have the bases are the parallel sides, and we need to name them sorry. We need to name them, for example, AB and DC. All right, so the parallel sides are our bases. All right, so then we have there are two pairs of base angles. All right, these base angles are uh, angle D and angle C. All right, and then we also have angle A and angle B. All right, and the base angles come in two sets. So for example, this would be a set and this would be a set. All right. And last but not least, we have the legs are the non-parallel sides. So if you erase all of my scribbling on here, the legs in this particular trapezoid would be AD and BC. All right, now that is a trapezoid in general. All right, now there's something called an isosceles triangle, and an isosceles triangle is if the legs of a trapezoid are congruent. All right, so this is the isosceles. I can't type today. All right, the isosceles triangle. And this is when the legs are congruent to each other. So, for example, this side and this side. All right. So with all of this information about trapezoids, we can actually make some conjectures, or in this case, we have two theorems that go along with trapezoids. All right, the first one, and they don't have any nice names. So in this case, we're just calling them Theorem 6-15 and Theorem 6-16. All right, but these pertain to how on earth can we tell if a trapezoid is an isosceles trapezoid? The first one states if a trapezoid is an isosceles, then each pair of base angles are congruent. All right, so for example, this one and this one. All right, the next one states a trapezoid is an isosceles if and only if its diagonals are congruent. All right, so if you look at the diagonals of this trapezoid, these have to be congruent in order to be considered an isosceles trapezoid. All right, so with all this information, we can actually draw some conclusions. All right, so in this case, we have using properties of isosceles trapezoids. We want to figure out if this is an isosceles triangle. We want to find the measurement of angle C, the measurement of angle D, and the measurement of angle E. All right, so what I'd like you to do is actually work this out in your whisk tonight, and I will check them in the next class. So make sure that you clearly label which measurement is C, D, and E, and it might be helpful if you even draw this figure in your whisk for you. It's always good to look back at your notes, and whisks are your notes. So if you could please do that in your whisk tonight. All right. So leaving the world of trapezoids, we now have our kites. Kites. So just to go over what a kite is, a kite is a quadrilateral with two pairs of consecutive congruent sides. So for example, this and this side, and this side. All right, and they're clearly labeled on this particular shape. So consecutive obviously means right next to each other, so it wouldn't be this side and the opposite side. Pretty self-explanatory. All right, and the next characteristic it has is that the opposite sides are not congruent, which I just stated. All right, so from here we actually have a theorem that we can work out. All right, so this is theorem 6-18. All right, and this states that if a quadrilateral is a kite, then its diagonals are perpendicular. All right, perpendicular, meaning that they are creating 90-degree angles, as we know. All right, and from here, we can actually use this idea to find the angles. All right, so PQRS is a kite. Exactly one pair of opposite sides are congruent. All right, so, or opposite angles are congruent, excuse me. All right, so that means that we are trying to find the opposite two angles. All right, with this, we need to figure out, well, how many degrees does every quadrilateral have? That would be 360. Well, we know that angle S is going to be congruent to angle Q. So we need to add up 75 and 55. All right. And we would get 130. All right, so then we would take this and we would say, okay, well, we're going to take 360, subtract 130 from it, because that will get us the amount of angles between the two. Divide this by 2. And we should get 115. All right, so each angle is equal to 115 degrees. All right, easy enough. All right, so we can also use this to find the side lengths. All right, so ABCD is a kite. Diagonals are perpendicular. So what I'd like you to do is actually use figure out how you would solve this. There's a very clear way to solve this, but you have to pull out some prior knowledge from algebra from this. So I'd like you guys to try this one in your whisk tonight and let me know what that trick is. Okay? So please do those two problems for me in your whisk. Otherwise, please come to class with any questions or comments. Thank you.